Well, yeah, that is possibly the coolest introduction to a song ever in terms of a bass solo. Answers on an email, please. If not the coolest start to a second order derivative video, which is what we're going to be doing today. So we're talking about differentiating twice, and that means what we're looking at is not only you would have noticed that our gradient functions, when we've differentiated, are giving us another graph, and you may have thought, oh, it might be possible to differentiate that. What would be the point? Well, the point is you're finding out the rate of change of the gradient function itself, so how that rate of change is changing, and that's very useful in predicting certain sorts of things. What things? Don't worry about right now. You might want to make a little note of how we write down second order derivatives. So here's our first example today. If you'd like to write it down and then have a go. The first one, dy over dx, is just meaning that you're going to differentiate it, and then whatever you get, the d2y over dx squared, the second differential, will be differentiating that. So give it a go whilst I have a ginger biscuit, and pause it, and then when you come back I'll take you through what you should have got. Right, so for the first one, dy over dx, we should begin by doing 5 times 3 is 15, drop the power by 1 to x over 4. But actually, before you even start doing that, that's me enjoying my biscuit too much, you see, we want to rewrite it so that we've got our power of x all written in a multiplier, don't we? So that would be 4x to the power negative 2. Then that's going to be easier. So we should then have dy over dx being 15x to the power 4, multiply 4 by negative 2 to give us negative 8, and that'll be to the power negative 3. And then when we come on to b, all we have to do for d2y over dx squared is derive this. So 4 15s are 60, x to the power of 3, drop the power by 1. Negative 3 times negative 8 is plus 24. That'll be to x to the power negative 4. Right, so this is the second form that you might see it in, function of x. Write this one down, have a little go at this. Remember, you need to start by turning your roots into index form. Going into index form then, if I just keep it as a function, we should have 3 root x is x to the power a half, and then we've got a half x to the power negative a half. So when we differentiate that, a half times 3, well, just write that as 3 over 2, x to the negative a half, and then a negative times a positive is a negative, so a half times a half is a quarter, so minus a quarter, x to the power negative, and taking another one off that, we can call negative 3 over 2. And when we differentiate that again, we just go through the same thing. We just have to be a little bit careful with negatives and fractions. So a half times 3 over 2, well, it's going to be negative because it's times by negative, so, and if I keep the 3 there but do 2 times 2 is 4, we get minus 3 quarters. and that will be to the negative 3 over 2. Negative times a negative is going to give us a positive, and it'll be 3 on the top over 8, won't it? Remember, you can always use your calculator if you're freaking out over fractions at all. And then taking another one off would be adding 2 more onto the top there as it goes more negative. It'll be minus 5 over 2. And that's all you need to do on that. So in many ways what you're doing today is just more practice at differentiating, but appreciating that it happens in two things. So have a little go at exercise 12H, and again I'd like you to do all of the exercise because different things can happen, weird and wonderful things, once you start getting fractions and square roots and negatives involved, and it's important to practice those as you go. And the more success you get at those little things, starting with the easier questions, the more enjoyable it ends up being. So exercise 12H on page 272, giving them all a go. And yeah, that question 4 should really make you think a little bit, but there's a little problem solving clue at the bottom there. So good luck with all of that. Bye bye maths friends, talk to you again tomorrow.